Hi guys, welcome to this set of videos, and this section of notes, what we're going to do is start a discussion on quadrilaterals. Now, quadrilaterals are going to be polygons that have four sides. A quadrilateral refers to any figure that has four sides. But in this sort of chapter, if you will, we're going to talk specifically about a certain kind of quadrilateral, and that's going to be what is known as a parallelogram. Now, before I get too far ahead of myself, and before we jump into all of that stuff about quadrilaterals and parallelograms, let's first go ahead and take a look at our essential question for this set of videos and this section of notes, and then the kinds of things that we're going to need to talk about so that you can answer that essential question. So, here it is. Let me highlight it for you. As always, our essential question we start off with is simply going to be this: what can you conclude about the sides, angles, and diagonals of, and there it is right there, a parallelogram. So in just a second we'll talk about what a parallelogram is, all right? And then we'll give you some information about the sides, the angles, and the diagonals of parallelograms. Once we know sort of the geometry behind parallelograms, then of course, like we almost always do here in this course, it goes back to algebra. So here's what we're going to do. Students will understand theorems and relationships about parallelograms. So that's exactly what I said we would just do. We'll talk about the sides, the angles, and the diagonals of parallelograms. We'll give you all the theorems, postulates, relationships, stuff like that. What is the geometry behind a parallelogram? Then from there, what you'll do is you'll need to be able to use those relationships to find unknown links, measures, and stuff like that, right? That's the algebra part. We'll have you solve for unknown things. All right, so this is going to go just like the rest of the chapters that we've been doing so far here in geometry. We'll learn a few geometry theorems, postulates, things like that, stuff about parallelograms, and then use that information to help us solve some problems. So here we go. Let's jump right into this. As promised, we're going to start our discussion off here with quadrilaterals. Now, in geometry, we have already talked a little bit about a polygon, and a polygon, poly, is just simply the Greek prefix that means many, all right? Poly meaning many. So when you're talking about a polygon, you're talking about a figure with many sides, all right? It doesn't specify a certain number, it just means a figure with more than one side, okay? Polygon, more than one. Okay, in this chapter, we're going to talk specifically about a quadrilateral, which is going to be a polygon that has four sides, all right? Quadra meaning four. So a quadrilateral is going to be any polygon that has four sides. Any figure with four sides is a quadrilateral. So just a quick note here, because this is a great definition, is a polygon with four sides, but essentially a quadrilateral is any figure with four sides. Any figure with four sides is going to be a quadrilateral. Any figure with four sides. And I've got a couple of examples for you right here of quadrilaterals. Now, the discussion on quadrilaterals really kind of ends there, right? As far as quadrilaterals go, it's just any figure with four sides. What we are going to look at in this chapter is a specific type of quadrilateral, and that's going to be what's known as a parallelogram. So, here we go. What we've got, oh, sorry, I slid up too far. Highlight this one because this is really going to be what we're going to talk about for the rest of this chapter. Parallelogram is, right there, you can see it, it's a quadrilateral, okay, but it's a quadrilateral that has two pairs of parallel sides. And you can see it right here in the diagram. I have a four-sided figure. That makes it a quadrilateral. But you guys will recognize the notation here in my diagram. The little arrow on AB and DC means that those guys are parallel. So I know that segment, oh sorry, that's my highlighter, I apologize. That means that segment AB is parallel to segment DC. Same thing here, double arrow means that those segments are parallel to one another. So AD is parallel to BC, right? And I can do those guys. Green is parallel to green. Red is parallel to red. All right, so what we're going to talk about here is a specific type of quadrilateral, and that type of quadrilateral we're going to look at is what's known as a parallelogram. It is a four-sided figure with two pairs of parallel sides. Okay, so just real quick, again, just to make sure we're clear, these examples up here, yes, all three of these are quadrilaterals. Yes, are quadrilaterals. But these three examples are not parallelograms. Yes, these are quadrilaterals. But these are not parallelograms. Right? Because I don't have two pairs of parallel sides, right? They just have four sides, but none of those sides are parallel to another side, right? So these are just simply quadrilaterals. We're going to look specifically at a quadrilateral, which we call a parallelogram because it has two pairs of parallel sides. Now, to help us answer our essential question, there are some relationships between the sides, the angles, and the diagonals of a parallelogram. So I've got another little diagram for you here. We'll go through each of these separately. First, let's start off with this one. A quadrilateral, of course, is a parallelogram. We already talked about that above. Here's the first thing. Its opposite sides are congruent. Opposite sides of a parallelogram are congruent. This is really important. So here we go. Let's go through this. What this means is that opposite sides are congruent. So SR is both parallel and congruent to side PQ. So the little hash means that they're congruent, they have the same measure, and they're parallel to each other because it's a parallelogram. Opposite sides. So SP is parallel to RQ. But in addition to them being parallel, the theorem also says that those sides have to be congruent. All right, so that's the first part of this theorem, the first relationship you need to remember. Opposite sides are parallel and congruent. They're the same measure. And I imagine you can already imagine the types of algebra problems I'll have you do. I'll give you a couple algebraic expressions for the size of those guys, and you got to figure out what you can set equal to each other to solve problems. We'll take a look at those in a second. All right, that's the first part. The next part of our theorem is this. Let me do it in a different color. We'll do it in blue. Its opposite angles are congruent. Opposite angles are congruent. If you would, for me for a second, just ignore the diagonals. Just ignore the diagonals. Pretend that they're not there. What I have is this angle S and its opposite angle Q. And the theorem says opposite angles are congruent. So here is the simple idea, and it's this. Angle S is congruent to angle Q. Angle P is congruent to angle R. Opposite angles are congruent. I could write that for you simply right here. Angle S is congruent to angle Q. Angle R is congruent to angle P. All right, so that's the next relationship in a parallelogram about angles. Opposite angles have to be congruent. And again, I'm sure you can imagine the types of algebra problems I could have you do based on this relationship, finding the angles of a parallelogram. So opposite angles have to be congruent. And then there's one more relationship here that we need to know about, so let me get rid of that stuff. Do it in a different color. Here's our last one. I'll do this one in green. Its diagonals bisect each other. Okay, so here we go. I've got the diagonals in my parallelogram. What does it mean that the diagonals bisect each other? Well, we've seen bisect in pretty much every chapter starting in chapter 1. Bisect simply means that it cuts a line segment into two equal parts. So here's what that means. That means that diagonal SQ is bisected by RP. So that means that this segment SO is congruent to segment QO, right? It's bisect. These guys are equal segments. It's cut in half. Vice versa, diagonal RP is bisected by SQ, which simply means that these two segments are congruent, okay? So those segments are congruent as well. That's what that third theorem is saying. Now, there's a little bit more to it here than even that I want to point out to you. So please note the couple theorems that we're going to use here. The first one is the alternate interior angle theorem. Alternate interior angle theorem. Yep, that's right. We're going all the way back to chapter 4 where we did angle relationships of parallel lines, which we already said. It's a parallelogram. So I know that these lines are parallel and they're cut by a transversal. What that means then, right? What that means is that these interior angles, right? Alternate interior angles are congruent. That one is congruent to that one. This one, right here, is congruent to this one up here, right? Parallel lines cut by a transversal. Alternate interior angles are going to be congruent. Vice versa, instead of doing those ones, I could do these two lines, which I know are parallel to each other, right? Opposite sides are parallel, cut by a transversal, so alternate interior angles will be congruent. That means that this angle is congruent to this angle, and this angle right here is congruent to this angle right here, right? Alternate interior angles, parallel lines, cut by a transversal, alternate interior angles are going to be congruent, all right? So you want to watch out for that as well. I absolutely will ask you questions about those interior angles that are formed by the diagonals, and based on the alternate interior angle theorem, you know that they're going to be congruent angles. Finally, one last one. I don't have to erase what I have there to do this last one. Guys, all the way back to chapter 4 again. Vertical angles. I have two pairs of vertical angles formed by my intersecting diagonals, which simply means that this angle right here is congruent to that angle right there because they're vertical angles, and this angle right here, oh, that's a terrible arc, hold up. This angle right here is congruent to this angle right here because they're vertical angles, okay? So we have all of our theorems about quadrilaterals, which you absolutely need to know, and we'll get practice with those as we do some example problems. But please don't forget alternate interior angle theorem and vertical angle theorem about some other angle relationships inside the parallelogram. I know that's a lot. We'll get a lot more practice with it here on the next page of the notes where we'll do some example problems together. So I'll meet you there.